to my workshop. My name is Robert. It's been nearly 7 months since I posted the last video. The reason is, a week after that, I bought this new to me lathe. Now this M300 has got a bed that's in much better condition than the old one, and it's a short bed model which gives me extra precious space in the workshop. I've spent the last 7 months refurbishing it, cleaning. It would have been a quick clean and paint job, but it had sat idle for so long that all of the oil all over it had turned to varnish, and it needed a complete disassembly to make everything work properly again. Anyhow, it came with a couple of extra toys. It came with a taper turning attachment, and it came with an Ainjest Rapid Threading Attachment. Now there's limited information on the latter available on the web, so as I needed to fix it, I thought I'd video stripping it down, reassembling it, and then do a video on how it works. So this will be the first in a series of videos on this because I couldn't squeeze everything into one video. So I hope you like it. Right, enough chat, let's get on with it. So this is an Ainjest Rapid Threading Attachment. It's designed to sit on the right hand side of the apron, so the apron will be here, and this handle engages a half nut underneath which connects to the lead screw and drives the whole carriage without using the half nuts in the apron. The idea of using this is that there's a mechanism in here which will only allow you to engage it at the right time for the thread you're cutting, and there's a mechanism down here for releasing the half nut when it reaches a predetermined stop. Now that means that you can thread at very high speed. For example, you could run the lathe at 800 RPM and cut at speeds which are far more suitable for carbide than you would be able to normally, because this will stop at the right place every time. This thing operates in the following way. We have a lever at the bottom here which you move across to enable it to be armed, and then you hold pressure down on this lever until the lead screw reaches the right point when it will drop in. On the back you have a cog which engages with the lead screw, which senses the position of the lead screw, and we have a half nut. We only have half a half nut here. If we rotate it right over, there's just half a half nut and just the support on the top here. So I've already removed the cover screws so I can get this thing apart nice and easily. What we have in here is this part which rotates with the lead screw. And when we have a suitable gap, as per here, it enables this to go in, if I can do this. And that has now raised the half nut on the back into engagement with the lead screw, and the carriage then follows the lead screw along. When we reach the end stop, and the end stop acts on a lever back here, that moves this over, and it's a bit stiff, snap, it comes off very rapidly. Zooming into this setting here, if that is in position 4, that enables you to cut threads with a whole number of TPI. This, by the way, is designed, this particular model is only designed for an imperial lathe. This is designed to work with, in this case, a 4 TPI lead screw. So if that's in position 4, there are 4 positions at which this will engage. And that works for any thread with a whole number of TPI. So 4, 8, 11, 13, that will work fine. If you are trying to cut a thread with a half number of TPI, so for example 11.5 TPI, you would need to go to 2. There is then only 2 positions where both of these parts line up. Similarly, if we go to 1, that enables you to only have 1 position per rotation and works for threads with 1/4 of a TPI. In position 0, there is no possibility of engagement, and that's the safe position. It's disabled. I'm going to proceed to disassemble this and clean this up and do some basic maintenance on it. Like so. Such. That's going to avoid this thing snapping back down and having my fingers. I'm next going to remove this spring here. Now there are some adjustment screws on this. These are basically Gibbs screws for the slide here. This screw here appears to be an adjustment for the action of this lever and when it engages and so on. And I'm going to leave that one well alone. But I do want to remove everything, so we have to find out how it comes apart. Appears this is pinned here. So that may well not come apart easily. Let's just remove these springs as well. This can come off. Oh, lucky guess. Everything's going to be imperial on this, unlike the rest of the lathe, which is all metric. Years of filth under there. A spring washer. That's metric, isn't it? Right. Bugger's muddle of... Yep, these are 6mm. There's a nut under there. Ugh. Encrusted with chips. Next we shall prise that off. And take this lever, marked A on the front side. It has the look of something that's quite hard actually. It's been ground on the back and it's quite shiny. Let's do that. No, these are Imperial. Yep. Is that going to help me? Not a lot yet, no. These ones are metric. Yep. Imperial, metric. That's bronze by the looks of it. Taking another good look at this, it looks like the half nut can be removed with a couple of cap head screws. It's one. And there's our half nut. And you can see where it's been driven in one direction all the time. And it's filthy. Right, I'm going to try and drill out this pin and or at least remove the top section of it where it's been pinned over to make sure that it doesn't come out. This thing has bearings inside here and they feel as rough as a badger's backside, so since this will run the whole time that the lathe is spinning the lead screw, well actually no, whenever the carriage is being fed, this really does need to be in good nick. So what I've got here, I've got this thing clamped by its base in the vise. I've used a edge finder to find the center of the spindle, so I know I'm bang on the center of the spindle. I can then line up this is a 4mm end mill, line that up with the top of the pin So I know that this is going to go straight through the middle. As far as I can judge, the hole has been drilled straight through the middle, not off to one side or at a slight angle. It looks okay. So then this is going to go straight down through the middle, so I only have to worry about lining it up front to back. I've done that. I've then got the rotational accuracy here to sort out. I spent some time fiddling around with that to get this end mill is just about the same size as the top of the pin. So I've got that lined up. I've then got this end of this spindle clamped in a V-block with a clamp on it. This will be the first time I've ever used this clamp. And I've got a clamp here holding the V-block so that the whole thing cannot rotate. So I've used the 4mm end mill, lined up again, found the centre between the vice jaws. I'm trying it this way now, gives me a little bit more room. I've got it clamped on this spindle and I've got the edge of this, the slide, the half nut slide, pressed up against the vice to try and keep it vertical, or at least aligned in the right orientation. And I've sunk a drill through there, which hopefully, just put 0 on that, if I move off, I should be, yes, inside the middle of this. So what I'm going to do now is to flip it over, repeat the process on the other side, drill as far as the spindle. And then if the pin appears to be quite thin at this point, hit the end of the spindle to try and shear the pin and get everything out, clear it out, re-drill the hole nice and straight, and I'll use a high tension pin, a roll pin, instead of whatever this is, taper pin or whatever it is. Well, I've flipped the spindle over, and by the time we reach this side of the spindle, this is about lined up. The DRO is telling me that I'm 0.5 millimetre further back this way with the drill. So this hole has been drilled at a slant. So yeah. That does look nicely centred. Didn't make too much of a mess there, that's pretty good. We're apart. There we go. It's free. That pin locks this part in place. Right, I'm going to have to drill this pin out. I've tried nipping it with a pair of side cutters to lift it out and it's pretty solid, so first things first, let's find centre. That's about as close as I can get to the middle of it. It's not quite in the middle, but it'll do. Now I can stick, I've got a 3.5mm drill with a little extension that will have to do. Okay, so this is a length of drill rod with a 3.5mm hole drilled up it and a grub screw on the side to hold the drill in. It'll give me the reach I need to get down there. I haven't got a long enough drill on its own, so let's give it a go. And as luck would have it, it's wandered. Okay, plan B. Make sure that's done up. I'm going to try and just skim the top of this with this end mill. Well, without damaging anything so far, that looks like the top is now flat. Well, let's see what we can do if we can get a punch mark right in the middle. That's in the middle. I guess my adapter didn't have such a good grip of it. That's deep enough. Well, I'm sorry, you missed it being tapped out. Right. That's what that is. It's a linear roller bearing. That's what that was on the diagram. There's a gib strip on this side. But if we look at this corresponding piece, it's just milled. Oh well, that's the way it was done. Right, so now with a bit more clearance I can set to, I'm going to have to drill this out. I can't see any other way around it. Right, I wasn't going to take the handle off, but it appears to have a roll pin in it, and it will be a lot easier to drive this out, and then I've got something to grab hold of here to align that. That's how I hoped all the pins were going to come out. Right, we've got the vise moved over. Every once in a while, stars align, and it turns out that's sat on some parallels, just about, to keep it level. And that is exactly the right height to just slip that in there. Let's just check. Play on. Like that. And there, ladies and gentlemen, is the pin. I think we managed to pretty much get that out without moving up the hole. A little bit close to this edge, but let's pull the pin back with it, so call that one a win. Let's give this a tap. There we go. You can see on the other side, that's where they pin it over so that it won't come out. Okay, I decided I'd give the pin in this part a bit of a tap, and out it popped. So now if I can get the camera to focus, you can see the top of the taper pin has just been ground to a slight bevel, and then they pin over to stop that coming out, which is a complete pain in the backside. It is a taper pin. If I if I just pop the calipers on it, you can see that it'll pivot on the top. It's slightly smaller at this end. I'll put some roll pins in instead. So here we have the exploded drawing of this assembly. And if you look carefully, you'll find there's a mixture of, it's 3/8 BSF, so that part there will have a BSF thread on it. That's M6, that's M6, then that's 2BA. It's just a complete mishmash of metric and imperial, which is nice. So this bar here is something I'll come to later when I get to make one for the lathe and show you where it mounts. I don't have these clamps either, so I've got to make those. But now the whole thing is pretty disassembled. I have it in this state. It's clearly not designed to come apart. Well, there we go. That's the thing in pieces. In the next video, I'll put it back together. I hope somebody finds this useful. But for now, thanks for watching.